I do this region right here. Do you understand where this region is? Yeah. Yay, excellent. So let's say I were to rotate this around the x-axis. I was going to rotate this around the x-axis. Could you tell me what the integral is going to be, Chris? What integral would I have to evaluate to find the volume of the shape spun out by rotating this yellow region around the x-axis? The integral from? Yes, of what? Nope, there's no negative. Someone help him? Keep going. Pi on the outside, yep.
Square root of x dx.
Square root of x, what? Squared dx. The radius squared, right?
Yeah.
So this is if you rotated it around the x-axis, Now, is this something you could solve pretty easily?
Yeah.
Yeah, what's the square root of x squared?
X.
So this is just pi from 1 to 5 of x dx. What's the integral of x? What's the integral of x? 1/2 x squared. And you're going from 1 to 5. So what's that going to be? Pi over 2 times 25 minus, what's 1 squared? 1. So what do you end up with? Pi over 2 times 24. So what is that? 12 pi. That's nice.
How did we get
How'd we-
pi 1/2 x squared?
How do we get that?
Yeah.
This right here is the antiderivative of that right there. That's the integral right there. Okay, that's pretty nice. Now, do I have to rotate that around the x-axis? Can someone give me a horizontal line? Give me a horizontal line that I could rotate it around instead of the x-axis.
Or y equals -7.
Sure, y equals -7, sure.
Oh.
I like that. No. No, it's fine. Y equals -7. So if I were to rotate that around y equals -7, where would that shape, so that shape would get flipped down here, right? It would be down here,
Yeah.
right? Does everybody understand that? So it's going to be a lot bigger. It's going to be a wider donut, much larger donut. So can someone tell me what the integral now is going to be? The limits of integration stay the same. So it's going to be the integral from what to what? 1 to 5. Pi is on the outside, right? But now this is not just a disk. There's something punched out of the middle, right? So what's the big radius? What's the big radius? So there's, the formula was, just to remind you, big radius squared minus little radius squared dx. What's the big radius in this case? The square root of x, what? Plus what? Plus 7, right? Exactly, because the big radius goes from here all the way to there. This distance right there is the square root of x, right? But what's this distance? 7. So what's the whole distance? The square root of x plus 7. What's little r going to be? What's little r the entire time? 7. So when you do this out, you end up with pi 1 to 5 of what? Root x plus 7 what? Squared minus 7 squared dx. Do you remember what I told you the most common mistake is on these integrals is? Do you remember? The what? Negatives is like almost always the most common, but in this case, what is it? Not squaring both of them. You see how both of these are squared, everybody? See these? Both of them are squared. Where do some people put the square instead? They put the outside the brackets there, and then you're like, oh, the 7 minus 7 is 0. And then you just have square roots, and then you're back to where you started, right? Can you do this one by hand? What's the first thing you need to do to this integral before you integrate? What do you have to do first before you integrate? What'd you say, Lindsay? Yeah, so if we multiply this out, do this for me. Start multiplying this out. Multiply this out and show me what, don't integrate, just multiply that out first for me. Multiply that out and tell me what you get. What happens? You need it to cancel, right? What's 3/2 times 2/3? What's 3/2 times 2/3? 1. So it cancels. What's 3/2 minus 1? These are not trick questions, everybody. I'm not giving you trick questions on Monday morning your senior year in May, okay? What's 3/2 minus 1? It's 1/2. Is that what we want the final exponent to be?
Yeah.
Yes. Now, is this something that's kind of annoying to do if you were to plug in 5 and 1?
Yeah.
Yeah, it's kind of annoying. Absolutely. Now, could you use your calculator to do this? You know how to do these things. There's really only 2 things that you really, at this point, need to absolutely know how to do. Differentiate on your calculator, and integrate. What's the one piece of that expression there that makes it kind of annoying to plug in 5 and 1?
2/3.
Well, the 2/3 is fine. You can deal with fractions, right? But if you plug in 5, right, it's going to be 5 to the 3/2. So could you plug in 5 and then leave it in radical form?
Yeah.
Sure, absolutely. But are you going to get an integer answer to this?
What is that?
Hold on. Please answer the direct question. I'm not trying to trick you. Is 5 to the 3/2 an integer?
Yes.
What does 5 to the 3 halves mean, everybody?
That's almost, is it like 5 times 2.5?
No, not at all.
It's the root. This is 5.
It's the square root of 5 cubed. Is that an integer? No, it's not. It really isn't.
I was joking with you, maybe.
Yeah. Yeah, so the way you could write that is, look, you could write it as the square root of 5 times the square root of 5 times the square root of 5. Well, what's the square root of 5 times the square root of 5? Not a trick question. It's 5. Is 5 root 5 an integer?
Yes. No.
Really? It's an integer? The square root of 5? Let's just move on. New scene. Okay, erase what's on the board, everybody. Erase what's on the board. What? Y equals -2? So what's this region going to look like if you were to draw the, kind of looks like this? Something like that? And you know, you can practice drawing the discs, I do, but the more you draw, the busier it gets and it's hard to see. But generally what I'll do sometimes is I'll do this, like there's the reflection of this piece right here. Hold on, let me finish, 1 sec. So this goes to there. Kind of like that. You see, but you see how many, no, you don't. I'm just saying, like, I'm showing you what it looks like. I could ask you, and if I do, you do have to. So just like y equals x cubed is a basic graph that you need to do, drawing rectangles and drawing curves is something you have to do. I could ask you to draw a slice. And this is what you would do. You would draw reflections like that, and then you just literally connect the things minimally. So like this corner is going to connect to that corner. So I usually do the outside ones. That's why I erase there. There you go. And then the inside ones kind of like this. So that's what one of them would look like. So what would the, sorry, Noah, go ahead.
Why is it not?
We wanted to actually do that one right there. We need to write the integral. What's the integral going to be? Pi on the outside always. What's the left-hand limit? 0 to what? To 3, exactly. And what's the big radius this time? What's the big radius? X cubed what? Plus 2 squared minus what? 2 squared dx. Exactly. Fantastic. Exactly. The big radius, here's the big radius right here, and then there's the little radius right there, and you square each of them individually. Now, you could integrate that one by hand. Because if you were to multiply this out, what type of function is this when you multiply it out? What is that? What's the general name for that kind of function when you multiply it out? It's not a quadratic, it's not a cubic, it's a 6th degree, but what's the general term for it? It's a polynomial. Do you know how to integrate all polynomials? Okay, everybody take out your calculator and do that one on your calculator right now. Do that on your calculator right now. 0 all the way to what? 3. We okay with this so far? So here's our region. It's the same region we had before, right? What point is this right here, just for scale? What point is that right there?
27.
Oh, you know what? Let's just do this instead. Let's just make it a little smaller, everybody, okay? Let's make this, instead of x equals 3 to x equals 2. Is it okay if I change that a little bit? Actually, you know what? It doesn't matter. I'll also change this to make it bigger. It's fine. We're gonna use, well, I'm sorry. I'm used to editing these so that we can do them more easily without a calculator, but since we have a calculator, let's just keep it. Let's just change the y, instead of y equals, so let's make it y equals 40. Okay? What point is that? 3 what?
47.
327, right? 3 cubed is 27. Is everybody with me? So where's that horizontal line? It's all the way at what? 40. I'm just making, this is not to scale, right? So could you rotate this? It would rotate what? It would rotate up instead, right? So what's this going to look like? Let me just create some more space here. Hold on a sec. So if I were to create some more space and then sketch what this looks like, yes, Natalie, you are absolutely right that you could rotate this up instead. What's it going to look like? You're going to have something like this up here, right? Do you see how that's the reflection up, everybody? No, that is totally not the reflection up. You're like, we're used to going with you on this stuff, Mr. Seamon. So if I were, it's a little tricky. Sorry, it goes like this, and then it's the outside of it, right?
Yeah.
Sorry about that. Is that better?
Yeah.
Okay, so what you want to do, there we go, something like this. That was better the first time, but everybody kind of sees what I'm trying to draw there?
Yeah.
So you have this right here. You absolutely can do this one, absolutely. So let's try it out here. Natalie, let's try it out. It's the integral from what to what? It's the same limits of integration as before. So it's going to be what? 0 to 3. What goes on the outside? What do we park on the outside of this integral? Pi. And then we have big radius squared minus little radius squared dx. Can you tell me what the big radius is? Draw where the biggest, what's on the outside? What is the big radius this time? Be really careful. If I were to draw the big radius goes from the center point all the way out the farthest radius. What's the farthest radius? What is this distance right here? This is big R right here. What is that distance? It's already written on the board. What is that distance?
40 plus.
Stop, everybody. Look at R right here. R goes from there to there. What is it?
40.
It's 40. The big radius in this case is 40. It is the outside one now, right? So what's the little one now? Be really careful. What's the little radius now?
40 minus x.
There it is. Excellent. Little radius is 40 minus what? X cubed. Because where is little radius? The little radius is right here. How do you figure out what that distance is right there? That's 40 minus what? X cubed. Are you okay with those two R values? Those two radius values? Raise your hand if you're okay with those radius values. Now you just plug it into that integral, and what do you get? Pi 0 to 3 of 40 what? 40 what? 40 squared minus 40 minus x cubed what? Squared dx. Now, is that something you want to do by hand? Not really. So what are you going to use? Use your calculator right now and tell me this to 3 decimal places, and remember to multiply by pi. Good job. Okay, so after you did W, can someone tell me, someone not David, tell me what you would do next? What's the next step, Chris?
You would make dx, or dw.
dw is equal to what?
Is equal to 1 minus ln x.
Nope.
Or the derivative of that.
The derivative of that. You need the derivative. So what is the derivative?
1 over x.
What is it?
1 over x.
Close. Negative 1 over x times what? Dx. So what does dx equal? Negative x what? Are you with me so far, everybody? This is really important. Do you see what we did there? David, I really like what you chose there. That I was literally going to separate it out. I think this is going to work a lot better. So what's next? Someone new here. Tell me what's next. Noah, yep.
Find dw. That's about it.
Find dw?
Yeah, dw is what lets you cancel.
Hold on. So we did this. What did we do after every time after we did this? What did we do next? Substitute. After we did that, we substituted. Don't apologize. So it's.
We want to find. Well, we want it to be negative dw.
Hold on. We don't want it to be anything. We literally do what Mark just said. What do we do? Substitute. So let's substitute. So what does the fraction become on top?
It becomes
W. X is on the bottom, and instead of dx, what do we write?
negative x. Or
Negative x dw. Does everybody see what we did there? This was step 1, and then what was step 2? Substitute. Yes. What haven't I written in yet?
What w is.
Careful. We haven't. What have I not written in yet? I've dropped something. What are they called? The what, Lindsay? The limits of integration. I didn't do that. Be very careful because you have to make sure you change them to w's, right? So what do you? These are x values, right? See those?
Yeah.
So what is w when you plug in 1? When you plug in 1, w when x is 1 is what? 1 minus ln 1. What's ln of 1? Do we have any idea what ln of 1 is? So what do you leave it as? Yes, you leave it as ln of 1. So this is what? 1 minus ln of 1. You can do it on your calculator, but leave it like that for now. And then what's the upper one become? W when x is e. 1 minus ln e. What is ln of e? What is ln of e? 1. So that's 1 minus 1 is what?
0.
So we go and plug this in and make it what? 0. Does anything... Now we look for the magical thing. What's the magical thing we look for? Canceling. Is there something that cancels, Natalie?
Yeah.
Sorry. The x's cancel, right? And what can we factor out to the front? So we have negative 1 minus ln 1 all the way to what? 0 of w dw. Is that about as simple as it gets?
Yeah.
As an integral, is it about as simple as it? Yeah, it is. What's the integral of w?
Oh, negative 1/2.
W what?
W squared.
From
1 to 0.
1 minus ln 1 to
1
0.
minus ln.
You have to be really careful about this.
1 minus ln 1 is 1.
It is?
ln 1 is 0.
Oh, ln 1 is what?
0.
0. So you could just make this. Excellent. Good job. Excellent. So what's the most common error people make at this point? The negative signs, right? So and what's the upper one? It's 0 first, right? So you have to do, was it negative 1/2 0 squared, right? Minus what? Minus what? Negative 1/2 1 squared, right? Well, what's this right here? What is that? That's 0, right? And what does this? What happens to those negatives? They become?
They cancel, so it's just 1/2.
So this turns out to be? 1/2.
If it's negative, can you just flip it?
You could. So what Mark is pointing out, everybody? Mark is pointing this out. See this one right here? You can, if you flip, so we could go back to here actually if you wanted to. You see this right here? If you flip the limits of integration, what do you do to the integral? Basically, I'm asking this. The integral from a to b of f of x dx, what is that equal to if you flip the limits of integration? It's the opposite, right? So could you have flipped them? Yes, Mark, you could have. Are you going to get the same answer? Okay, so how confident are we on this work right here? How confident are we? I'm pretty, I've seen some head nodding. I'm pretty confident. What could we do to check our work?
Find the derivative.
So that's actually a really good answer, thank you. But the challenge is we're down to a single number, right? Like, there's no way to undo that with a derivative. We could use our beep, beep, beep. We could use our... Well, no, but hold on. That's actually a really good way. That's actually something I hope we will use one day, and we will redo curriculum so that we can use something other than these terrible calculators. They are terrible. I will go on record. They are 20 years old, and we still use them. They are great for what they do, but we need to evolve when they haven't. We could use our calculator, everybody. You run this on your calculator, everybody. Do this integral. Do this integral on your calculator, and let's see. Check that with the calculator. See what it comes out. Pi, right? And it's between the x-axis. Find the exact area between. Oh, wait, excuse me. This isn't a rotational one, right?
No, it's not.
So this is just 0 to 5. What's the function? 2x e to the x squared dx. This is just a what? What type of integral is this? What do you have to use? What method do you have to use? This is a definite integral, but what method do you have to use to integrate this? We only know like one method. W substitution. What do you think W is going to be, David? Since you got this right before, what do you think W is going to be? What? Exactly. Do this out right now by yourself. You guys should be able to just totally... What's dW equal to, David? 2 dx. So what does dx equal?
dw over 2x.
We've done this so many times. So that was isolating. So now we substitute. So it's the integral from what to what now? 0 to what?
25.
To 25. 2x e to the what power? W. And then you have dw over. And does something magical happen now? Oh, that's so nice. So you end up with the integral from 0 to 25 of e to the w dw. What's the integral of e to the w? Yeah, so you have e to the w from 0 to what?
25.
So what's the answer to this? E to the what?
25
Minus 1. Is that a big number?
Yeah.
That's absolutely a big number.
Wait, what is